Now that we have a version of our cutter tool that we're pretty happy with, let's go over saving and updating HDAs. So we can zoom into our cutter geometry subnetwork here, and if you select that and right click on it, there's this create digital asset option here. So select that, and this will prompt you to select a location to save it to. I generally just leave this save location set to the default, which on Windows will be under Documents and the Houdini version, and a folder called OTLs. HDAs used to be called OTLs in earlier versions of Houdini, and you'll sometimes see this hanging around as a legacy name. And some people that have been using Houdini for a while still call them OTLs. And you can format this HDA file name however you'd like. In my case, I have an existing cutter geometry HDA file, so I'm just going to use the file browser and select that. Although, you have to be very careful not to change the operator name. This is the internal name used by Houdini to identify the node type. This can't have any spaces in the name. This has to be all regular characters. And this label we can change later and can have spaces and etc. But the name is more strict. And because I have other scenes where I've used a version of my cutter geometry HDA, I really need to make sure that this operator name does not change so that those existing scenes can still find the node and they'll still work. You don't have to worry quite as much the first time you create it. You can just set this to whatever node name you want. I usually get rid of that user ID that it adds to the beginning, and I like to format the caps on this nicely for the label. But I'm just going to cancel that for a moment and double check the name of my node so that I don't mess up my other scenes. I'll tab and create a cutter geometry Keith Digital node and right click that. Let me move that up a bit for you so it's not off the screen. Right click and type properties. You can see here it says the operator type is cutter_geometry_Keith Digital. We can also see that if we right click and go to show an asset manager, and this also shows you the name there. So now that we know that that's the real name of the node, let's close this. And I've already backed up my existing version. So we can go back to our subnet, right click on that. We'll say create digital asset. I'll point to my existing HDA file, change the name to match what I know the real name is of that node, and hit accept. Now that's created that HDA file on disk, and it brought up the type properties for our HDA. So we were using two inputs of our subnet where we set up that cutter generator. So this defaulted the node to have a minimum inputs of 2 and maximum of 2. However, that second input is really optional, so we can change the minimum to 1 and leave the maximum at 2 so that you can decide whether or not to use that extra input geometry. Under parameters, you'll see all of the parameters that we set up under Edit Parameter Interface on our subnet. This is all the exact same UI. And you don't have to worry about most of these other tabs in here, but if we go over to Input and Output, it can be helpful to label those inputs and outputs so that you can get a hint when you hover over them. So for that Input 1 label, I'm going to call this Cutter Area Geometry. And for the second input, we'll call this Extra Cutter Geometry. The output is less important because it's pretty obvious, but I suppose we can just call this cutters or something if you would like. So you can hit apply and accept. And now when we hover over each of those inputs and outputs, you can see in the bottom of our network editor here, you have those label names that we specified. Now those changes we've made in the type properties window haven't actually been saved to the HDA file yet. They've just been saved to this local live copy of the node in our scene. Now you can see this little unlocked lock icon here next to that node, that means there may be local changes to this that are not synced with the version that's on disk. Now this isn't just for custom HDAs, this is also true for general Houdini nodes. For example, if we drop in a Boolean fracture, you can see this has a lock icon, which means it's in sync with the asset definition. But if you right click on that and allow editing of contents, that means we now have a local copy of that that may have changes that are not synced with the main definition. So you could rewire this Boolean fracture to work differently and have this unique copy of it here. Now we don't want to mess with the definitions of the built-in Houdini nodes, but for our own HDAs, we can easily save those changes to disk. If you right-click on this and select Save Node Type, that will write all of these local changes to that HDA file, but it'll still maintain an unsynced live copy in your scene. If you want this copy in your scene to be bound to the HDA file on disk, then you can right-click that and select Match Current Definition. I think that's a little off-screen, so let's move it up, right-click, Match Current Definition. And now you can see that this lock icon means it's in sync with that main definition, and if you dive inside, we're not able to edit any of this stuff. Now, I overwrote my old version of the cutter geometry tool with this new one that we built from scratch in a subnet. But typically, that's not how you would want to update existing HDAs in your scene. Typically, you would want to grab a copy of the HDA and unlock that like we saw a moment ago, right-click, allow editing of contents, and then you can dive inside and make your changes and then save that node type once again, and you don't have to worry about those important node naming issues that I mentioned earlier. Because like I said, it's very important that this node type name never changes. Now since we've just been going over making changes to an HDA and saving those, let's make a couple improvements to our cutter generator. One thing to watch out when changing the parameters is to not do it with the Edit Parameter Interface option. This is extremely important, and I can't emphasize this enough, because once you have an HDA that's saved to disk, you really need to make all of your changes through the Type Properties window, like so. If you try to just edit the parameter interface and then save node type, any changed or added parameters will not be included in what is saved to disk. So in this case, I do want to change one of those parameters, so let's do that in the Type Properties, and we'll go to the parameters here, and on our padding multiplier, we're currently using, let's see if I can expand this enough, we're using this padding that's based on the Y size of our input geometry. Now in the previous video, we used a double max function lookup to find the maximum dimension between X, Y, and Z. So let's just copy that from inside our network here. If we go to our grid, we're using that on our size expression here. So I'll just copy this double max function from there. We'll jump back out, go to the type properties on our cutter generator, padding multiplier, and instead of this B box for the Y size, let's paste that double max function in there. And this looks, it's very difficult to look at, but essentially this is just going to take 10% of whatever the max dimension is instead of just 10% of the Y dimension. So let's apply and accept that. Now I mentioned in a previous video that it is a bit risky for us to do our trimming to the object area before we apply the higher frequency mountain noise. If we zoom in here, you can find some areas where the cutters are being pushed inside the mesh. There's one spot over here, and that could generate some invalid cuts because you have that not passing all the way through our geometry. And I'm sure we could find some others as well if we hunt around. I won't spend too much time trying to hunt for those. And we can reduce the problem to some degree by using this expand trim object option that we made on the HDA. But even if we expand that to double what it is right now to 10, it looks like it's still not fixing it in some of these areas. Reset that to 5. Whoops, not 105. Let's escape, back to 5. And now let's use a little hack to do some better grouping based on the volume. So let's make a reference copy of our high frequency mountain noise. So right click that, actions, reference copy, and we'll pull this up to where we're doing our object-based grouping. Let's hold Y and slice across that. Now, we haven't applied the subdivide to these lower resolution meshes. We don't really want to run a subdivision on everything because that can be pretty slow. But we can still use this mountain noise, and this is going to inherit the same exact values from our mountain down here since it's just a reference copy. And this will apply an identical noise to this lower resolution mesh. So now if we do that, we can group based on this noised up geometry. And this will sort of predict the position that the cutters will be in when you apply the noise later. Now we can't just leave our grouping and our deletion as is because this already has this high frequency mountain applied, and we just want that to be applied later once we have a little bit more resolution. So we're going to use a group copy to get this group data back onto our low frequency meshes. So let's go down here and drop in a group copy node, and we'll connect our low frequency cutters to that, and let's grab this promoted trim area and put that into the second input. And then on the group copy node, you can select the primitive group trim area, and we can make sure this is working by comparing the number of grouped prims. If you middle mouse on this group promote here, you can see this is containing 22,000 prims, and in this group copy, you can see this contains 63,000. Now we're using the same group name for a couple layers of trimming. We have our bounding box using a trim area here, and that's got 63,000 prims. So this group copy isn't working yet. It's just keeping that same prim group due to the name conflict. Now I think it should give you a warning about this, but if you look on the parameters for this group copy, there's a group name conflict parameter here, and you can see it's skipping any of those groups. You can set that to add suffix, which will change the name of that group. It makes it trim area 2, but in this case we just want to overwrite that. So now, just to make sure this is working correctly, we have 22,000 here, and now that is copied over. We have 22,000 on our destination geom. Then we'll just drag our blast down and use our new copied group to do that blast. And if we zoom out a little bit and toggle that mountain on and off, you can see how it's affecting the trimming based on that high frequency noise prediction. Now it looks like this trimming is still happening a bit too close to the geometry. So in this case, it doesn't look like it's going to fix some of our cutters that are being pushed inside there. We probably just need to increase our padding multiplier on this one, but you can just take my word for it that this will probably save you a lot of headaches with cutters being pushed in by the mountain noise. Now let's wrap up our updates by taking a look at this padding multiplier, because it looks like a much smaller padding amount than we should expect. So if you left click on that parameter, that'll switch between the expression and return value, and it's just giving us a value of 1, so something must be wrong with that expression. And yes, sure enough, we copied this double max lookup from our grid geometry inside our tool here. And in here, it's referring to our input geo, the null at the beginning of that setup. But on our HDA here, we don't have a null called input geo. We just want to use the number 0 to look up the first input. So we need to just change our parameter one more time. Once again, do this in type properties, never in edit parameter interface. We'll go back into our padding multiplier and just go through this annoying process of changing all of these input geos, should be 3 of them, to the number 0 instead. Got X and Z, just one more for Y, and let's accept that. Now sure enough, you can see this padding multiplier is now returning a value of 20. That's much better padding amount than 1. It doesn't look like a ton of padding because we have this trim outside object turned on. So if we turn that off, you can see we have a lot more padding, and then our trim outside object option will now be a bit more effective since we have that predictive noise that's factored into that volume-based grouping. So to finish this off, we will go back to our cutter geometry, HDA, we'll say save node type, and then we'll right click it again and match current definition. Now we have our nicely updated tool that is synced to the master definition on disk.